Hello, so today we're going to be beginning our unit on graphing quadratic functions, and there is a lot that goes on in this unit. So a quadratic function is where the function of x is equal to ax squared plus bx plus c, where a, b, and c are constants, a cannot be 0, and the highest degree is 2. The graph, when we do this, is called a parabola, and it usually looks like an upper angled U or a upside down U, either one of those cases. The vertex is where it changes direction, so it's like the lowest point or the highest point. Those are called the vertex. A vertical line that passes through the vertex and divides it into two symmetrical halves is called axis of symmetry. So if I were to divide it to where it has two mirror halves, this is called the axis of symmetry. It goes right through the vertex, and it basically creates two equal halves. If you fold it in half, they would lay one on top of the other. There's information from a quadratic function that's important, and we're going to be using it quite a bit today. It's a quadratic function. There is what they call a parent function, which is where it starts, and this is when the axis of symmetry is the y-axis. Okay, so if I have the function of x where y equals x squared, so this y equals x squared, that's your parent function. Okay, the vertex is at origin, and the axis is the y-axis. That's the axis of symmetry. Vertex form, this is because it is no longer the parent position. It has moved, it's shifted. It's either moved left or right, up and down, or any of the above. And so when we have that, we call this the vertex form. And this is y equals a times x minus h to the second power plus k, where h and k is the vertex. Okay, and that's going to be very important. A determines which direction the graph is opening and if it's narrow or wide. If it is a positive A, it means it's opening up. So it's going to go up. And it has a minimum value. Where the vertex is, that's your minimum value. A negative A means the graph is opening down. And so the vertex in that case, this is going to be the maximum. So this is the max. And this is the minimum. Okay? If I have absolute value around it, it makes a narrow graph, and it's greater than 1. If it's got the absolute value of A and it is less than 1, then it's a wide graph. And we'll work on that here in just a little bit. H, remember in the vertex, H and K make your vertex, where H and K, so let's do H is your x and K is your y. So H is telling you if it's moving to the left or to the right. And if it's greater than 0, it's moving to the left. And if it's less than 0, it's moving to the right. And think about that. H, that's your x value. And x-axis, if it goes to the right, it's positive, and if it goes to the left, it's negative. So that kind of makes sense. K is your y value. And that's the one that's telling you if it's moving up or down from the parent. And then the domain is all real numbers. It's the values of x. And range is if y is greater than or equal to a certain number, it occurs at the vertex, or again, it occurs at the vertex. We'll get used to those here in just a few minutes. So this is reading strategies. I included it in your note packet. This is for 19.1. It talks about the parent. So this here is an example of a parent. The vertex is at 0, 0. It is opening up, so it is a positive A. It's opening wide, and so it has a stretch. And this is what you call a parent quadratic function. Let's see. So let's take a look at your A. So A is your coefficient in front of your x squared. And so if A is greater than 0, it opens upward, just like the parent. If it is opening downward, it's negative. If A is greater than 1, it looks narrower. If A is between 0 and 1, then it looks wider. So if it's a fraction or a decimal of any kind, it'll be wide. Okay. If A is less than 0, it's reflected across the x-axis, and it would be going downward here. And 0 is the maximum value. If A is less than -1, it's going to appear narrower, so it'll be narrower than the original. If A is equal to -1, it's exact same width as the parent. It's just going downwards instead of upward. And if it's between 0 and -1, it looks wider, but it'll kind of come out like this. So it's going to be much wider than the parent one. All right, so we're going to graph each equation and give the axes of symmetry. And what we have here is -1/2 x squared. And when we're working through these, pay attention. If it's a fraction, we want to find values for x that is multiples of the denominator. So in this case, I'm going to do 4, 2, 0, -2, and -4 for my x values. So if I have -1/2 times 4 squared, that is -1/2 of 16. Half of 16 is 8, so it's going to be a -8. If I have -1/2 of 2 squared, it's -1/2 of 4, which is -2. 0 times -1/2 times 0 is 0. And if I switch these to -1/2 times -4 squared, -4 times -4 is +16. You'll notice that it's the same. And same thing for the 2. Now that I have some numbers that I can graph, then it's a lot easier to figure out how to draw my graph. So when I look at these, I see that I have positives and negatives. I also have a vertex. This is my vertex. That is at 0. So I know that I'm going to have 0, but then all my y's are below 0. So I am actually going to draw my lines for my axes. And then I'm going to plot my points. So I have 4, -8. So there's 4, 1, 2, 3, 7, 8. 2, -2. 0, 0. -2, -2. And -4, -8. Drawing these a little challenging, so excuse me while I try to do this. Okay, so my vertex is at 0, 0. My axis of symmetry, that's what this is, axis of symmetry, is the y-axis, so it's at 0. So x is 0. The domain, remember the domain is your x values, and if this kept going, it's widening, isn't it? Okay, so that means that it is to positive infinity and to negative infinity. So I'm just going to put my domain as infinite. And my range, see how this is my vertex? That means that my maximum is 0. So y is going to be less than or equal to 0. I can't go above 0, but I can definitely go below 0 with all my y values. Okay? Alright, so this one I have f of x. So the function of x is 2x squared. I am going to pick 5 values for x. And so I just like to go ahead and work them through. Oops. I want that one to be -1, 0, 1, and 2. Doesn't matter which order you go in. So if I have 2 times my x squared, and if my x is -2, -2 times -2 is 4, 4 times 2 is 8. If I have -1 squared, -1 squared is -1 times -1, which is 1. 1 times 2 is 2. If x is 0, 0 times 0 is 0. 0 times 2 is 0. 2 times 1 squared, 1 times 1 is 1, times 2 is 2. And 2 times 2 squared, 2 times 2 is 4, times 2 is 8. And you'll notice that these numbers, they just reverse the order. Okay? Now I notice this one, my y's are positive, my x's are positives and negatives, and I use the origin. So when I draw my lines for this one, for my axes, I'm just going to go kind of make my origin down a little further. And so now I'm going to plot the points. So I've got -2, 8. So 1, 2 is there. 1, -2, or -1, 2 is there. 0, 1, 2, and 2, 8. They're supposed to go through the dots. This is going to be a challenge today. There we go. And you'll just have to pretend that one's going through the dots. Alright, so not very pretty, but on the program that's a little hard to draw. So my vertex is at 0, 0. So it's at the origin. My axis of symmetry is the y-axis, so x equals 0. My domain, as it's going up, it is minutely, but it is opening up, and so I know that it's going to be, my x values are going to be infinite. My range, my y values, see, this is where my minimum is. See how it's going up? So my y values are only going to be greater than 0, equal to or greater to 0. They're not ever going to be less than. So y is going to be greater than or equal to 0. On this one, I have, so this is where we have our formula where we have a times x minus h plus k. And remember that a and k are my vertex. Okay. And that's going to help a little bit. I still want to find my values for plotting these points. And I'm going to have -2 times, let's go ahead and go with -2. Minus 1 squared plus 3. -2 minus 1 is -3. -3 times -3 is positive 9. 9 times negative 2 is negative 18. Negative 18 plus 3 is negative 15. If I have negative 1, negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 3 is 5. Negative 5, sorry. If x is 0, negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 3 is 1. If I keep going, let's do 1. So if x is 1, negative 2 is 1 minus 1 squared. That's 0. 0 squared is 0. Times negative 2 is 0. Plus 3 is 3. And then at 2, negative 2 at 2 minus 1 squared plus 3. That's 1. 1 times 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus 3 is 1. And you'll see that, see how it reverses directions now? This is actually going to be my vertex. Sometimes they're a little harder to find. And sometimes they don't line up very pretty. And so I have negative 2 times 3 minus 1 squared plus 3. 3 minus 1 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 3 is negative 5. So now that I've done that, I'm actually going to graph these 5. Okay. All right, so I see that my y's are negatives and positives. So I need to make sure I center it a little bit more. So I'm going to put it more centered, I think, this time. We got negative 1 to positive 3. So negative 1, 0, 1, 2, negative, or 3. All right. Plot these points. I'm going to plot negative 1, negative 5. Negative 5, 1, 2, 3, 4, 5. 0, 1. 1, 3. 2, 1. And 3, negative 5. So you'll notice this time so I have a parabola that's opening down. My vertex is at 1, 3. My axes of symmetry, in this case, let's see, is going down right there. So it's at where x is equal to positive 1. And my domain is infinite. And my range, my minimum is my y value at the minimum, or the vertex is 3. So, so it goes less than 3. So y can equal 3, but it also can be less than 3. And so y is less than or equal to 3 describes my range. Remember, it can never go over the highest point. In this case, it would be 3. Okay, let's take a look at this one. I have 3 times x plus 1 squared minus 4. I'm going to go ahead and work out the problems, and then I'll show you my work in a moment. All right, so I did some solving. I started with 2. 23 is rather large, so I kept going down by 1 each time for the value of x, and I see that I have a mirror here. So those became my 5 that I'm going to choose to graph. When I'm looking at this, I do have positives and negatives, so it needs to be fairly centered. And then I only have 1 positive and more negatives, so I'm actually going to put the y-axis a little more on the right side of the graph. All right, so I drew my graph, making sure I had at least 8 up here so that I could plot my 1, 8 and my negative 3, 8. And then I drew my parabola. So when I look at this, my axis of symmetry is here at negative 1. My vertex is here at negative 1, negative 4. My domain, because it's arrowing, is an infinite number, all real numbers. And my range is y is greater than or equal to negative 4. Greater than or equal to negative 4. Okay, come back for part 2.